And it takes me back to the first day of my freshman year at UC Berkeley. When I walked into the classroom, I didn't know it at the time, but the classroom of the professor that discovered brain plasticity. Her name is Marion Diamond, and she was the very first female PhD in neuroanatomy that UC Berkeley ever gave. I walked into her classroom in the 80s when I went to college, but she discovered this in the late 1960s, when it was thought, as you said, that the adult brain can't change at all. There's absolutely no evidence for it. And that was true at the time. She thought, I don't think that's true. Let's do a simple experiment. Let's try and look at the effects in two randomly grouped set of rats, one that lives in what they would consider an enriched environment. What would be an enriched environment? Well, for her, it was a rat cage full of toys that got changed out all the time, lots of other rats to play with, and lots of activity. I think of it as the Disney World of rat cages. And she compared the brains of those rats to rats that she raised in kind of a shoebox, a smaller environment. They got free food and water, all the food and water they could eat and drink, but maybe only one other rat and no toys. Now, if the adult brain, they were all the same age, they were adults. If the adult brain didn't change, then there should be absolutely no difference between the brains raised in Disney World and the brains raised in the shoebox. But she found that the brains of those rats raised in the Disney World of rat cages, the outer covering of the brain, the outside of the brain here, I'm pointing to the outside of this brain model here, called the cortex. It was actually thicker. She was a neuroanatomist, and she showed that the thickness of this outer covering actually grew. What does that mean? There were more synaptic connections there, not in the whole brain, in certain brain areas. That made sense. The visual cortical area, there was much more visual stimulation in the Disney World of rat cages. The motor areas were thicker. The somatosensory, the touch areas were thicker because they were interacting in a much more complex way with their touch system. And that was the first demonstration the adult brain could change, and that it would actually make the cortex of the brain grow. And now we know, what is it about the Disney World of rat cages? Is it the toys? Should we all be playing with toys? Later studies showed that you get almost identical effects just by giving rats a running wheel.